This video is a tutorial on how to vote on the Dynamo blockchain using the command line interface and the web wallet. This is for our upcoming proof of stake, proof of work split vote. The vote that you're going to issue is how much percentage the miners should get of the one Dynamo. So, if you vote 60, that means that the block split is 60%. The block mining, the voting starts at block 156200. So all of the balances that you want to vote should be in place at that time. We will count the addresses balance as of that block. So you want to just make sure everything's in place. And then voting is going to go until block 1.6 million. And votes before or after that time frame will not be counted. So you want to make sure that you get your votes in. It's about 10 days total. So I want to show you some of the code behind the voting. This is the CLI code. It's written in C#. It's available on the GitHub repo. There's a binary release as well. So basically this thing asks a whole bunch of questions about your RPC. It then aggregates up your balances by address, and then it in a loop just goes ahead and votes all of them. I want to make an important note here that it will dump a log text file, and that text file will have unencrypted copies of your keys, so just be really careful about that text file. That's why that warning is there. So the message that it's mining is 020000 plus your vote plus the proposal hash, which is that magic number there, which you can find in the article, and it's just a random number that's been generated for this purpose, and then followed by the address of the wallet that's voting. The next step is that it will sign that message with your private key for each address, so that you know that that the originator was sending and signing this message. This is the part where the RPC call is going to dump the private key again. So you just want to be really careful about that log file if you select to have debug logging on. So the message is then appended with the signature, and then the signature gets put into a transaction and submitted onto the chain. You'll then be able to view that transaction on the chain, and I'll show you in a minute how to verify the signature, and that will prove that whoever sent that vote was able to sign it using their private key. All right, now we'll have a look at the JavaScript code. This is the code behind the web wallet. It's largely similar to the C# code, except that it's using the Bitcoin.js library to sign transactions instead of using the RPC. Obviously, there's no RPC here. So you input the transaction ID that you're voting, again, that hash. You input your vote. It opens the wallet and retrieves the master key. It then forms the same message. So that's the opcode plus your vote plus the transaction ID plus your wallet address. It then gets the next root private key and passes it off to the signing routine, appends the hex of the signature to the message, and then sends it off to the chain to be mined in. Okay, so let's go ahead and run the command line utility, and I'll run through an actual voting procedure. So I'm going to type in the information related to my RPC. I'm running a full node. If you're running Qt, that's also obviously a full node, and so you'll type in the same information. I have a wallet called test vote with a few coins in it. If you have multiple wallets, you'll need to run this program multiple times, one for each wallet. It only opens one wallet. If you have a password, you can enter it here. Otherwise, just put blank. This allows you to filter out small balance addresses. So if you have addresses with lots of tiny amounts, in particular less than the fee of 0.0001, then you'll want to filter that. I'll just use like 0.1 here as an example, but if you have lots and lots of addresses, you want to use that. And then this is the magic number hash from the article, which is the transaction ID that we're going to vote. And then the next is our vote. Obviously, for a normal vote, we'd be voting yes or no. In this case, I'm going to enter the amount of percentage that the miner should receive of the 1 DMO per block. So, if I put 60, that's going to be 0.6. In my case, I'll vote 20 just because it's a non number, right? So it's not a valid vote, but that would mean 0.2. And also, just to be clear, no numbers besides 70, 60, 50, 40, 30 will be accepted as votes. Those just simply won't be counted at all. So 20 is an invalid vote anyway. And then this is, again, the warning, just telling me that the log file, if I choose to dump debug logs, is going to contain my private keys. It contains a log of every RPC that was run, and any errors and so on. So if you do want to have a log file created, just be aware that you need to secure it, delete it, empty the recycle bin afterwards, whatever, but it will have all your private keys, unencrypted plain text, stored in it. Okay, so it scanned my wallet. It found 3 and some coins change. It just asked me to confirm the details. I'm going to go ahead and say yes, and then it's going to create the transactions. Once I create those transactions, I get 3 transaction IDs. So I only had 3 outputs in my wallet. It just created one, so there's 3 different addresses that have been voted. And then I can go ahead and take those and look them up on the blockchain using the Explorer. So you can see here, this is a sample transaction with the no-op mined in. My output was 1.998. I got 1.9997 back. This is the hex, and so you can see the opcode and my vote, and then the transaction ID hash of this proposal or this proxy vote. And then you can see my decoded address and the signature. And this is, again, a standard signature that's used by Bitcoin Core to sign transactions. And I'll show you in a minute how to use a website to decode and verify that transaction. So you get one transaction ID for every output. This is just one sample, but however many different balances you have, you'll have that many different transaction IDs. Okay, so now we're going to try the voting in the web wallet. This is a sample wallet that I have. You basically just pick vote. You put in that transaction ID. Again, just note that when you paste the transaction ID, it's going to scroll off on the UI. These text boxes don't horizontally scroll, but it is fully there, and it will be correct. It's just you're going to see that funny thing on the right-hand side. And then the vote, again, same thing, 2 digits, the percentage for the proof of work split, put in my password, and I hit vote. That's going to create the transaction and send it off to the chain. I'm only voting my one address in that balance, so just to be clear, it's not multiple votes, it's just the one address that's in the wallet. So it submitted it to the chain, and then I got my transaction ID back. Note again, the GUI is a little funny here, but the transaction ID is able to copy. So I just click copy. I can put it on the clipboard, and then I can go like paste it to Notepad or something else. But that's kind of your record of voting on the chain. All right, so we can go look up this transaction ID that was generated, paste it off there, and you can see it's basically the same thing. There's in this case 2 inputs, and then my change and my voted coins. So same basic idea. Now I'm going to show you how to verify that the address was actually signed, that the message was actually signed correctly. So I found this website which allows you to put in an address and put in a message. You can see here I've typed in the message that's the voting opcode. In this case I voted 10%. It includes the hex of the transaction key, of the transaction ID, and the hex of my address, and then I put in the signature which I decoded, and if I click verify it says that it's a valid signature. You can see if I change anything in the message, it's going to say invalid signature, so we know that the message was signed by that person. And because the vote includes the voting opcode, the vote that was actually cast, their sending address, the hash of the transaction that's proposed, and the signature, we know that it's a valid vote, and so it can be, anyone can verify that their vote or anyone else's vote is valid. So we'll use this as part of the voting validation procedure. All right. If you have any questions, just hop into Discord and ask, and hope to see you in the vote. Thanks.